Okay, this is lesson 5. We're looking at potentiometers, or also known as variable resistors. We're going to talk about the basics of potentiometers and how a potentiometer works. We're going to put the hardware assembly, and then we're going to code for a potentiometer. Potentiometer is a resistor that you can adjust. We use a potentiometer to control the brightness of an LED, control a server, adjust the volume of a music player. Potentiometers contain a resistive element inside with two stationary terminals. It's also known as a wiper that can move in a clockwise fashion along the resistive element. Here's what that means, folks. If you took a 9-volt battery and you put it on your tongue, you would get a little shock. You'd taste it. It tastes metallic-y. But if you would take those probes and move them closer and closer in your tongue, you would find that you would get a bigger and bigger shock in that. So the farther current has to travel, there's more resistance. We have that problem in wire, high wire that delivers energy from the power plants to our homes. We lose energy that way. So, some of our energy that way. So, we use that fact to, with the resistor material here, if you can look at the stride, and there's the wiper. If that wiper is closer to the least amount of resistance material, it's going to have low resistance. Over to the right here, it's going to be high resistance. So let's put this together. And we're starting to give you some diagrams so you get used to this. This is a resistor 330, a ground. Here's the potentiometer. Notice it's just got like a resistor here, but there's no value with it. It's a potentiometer. It's going to pin A0 on the breadboard because this will be a variable resistor. It's not digital. It can be a whole range of values. And then it's also hooked into 5 volts. Over on the other side, we have on pin board 13, we're hooked to an LED light. We have a resistor and we're to a ground. And so this is how it looks right here. Okay? So, with that in mind, we are going to be doing some hooking up here. So we've got our potentiometer, a little blue with the arrow. We have an LED hooked up to pin 13. The red and ground, the hot and ground are going right here to 5 to the ground. A sub 0 is coming over here in the middle of the potentiometer. Top is going to the ground. Bottom is going to the hot. Okay? And with that in mind, take a moment here and let's go ahead and build this. You might as well pause. Let's talk about programming. All right? Now, we're going to begin by programming, and we're going to define a couple variables. We're going to have a sensor pin. That's going to be A0. We just refer to it as 0, semicolon. LED pin 13. This is the pin for our LED, our output on this. And then we need a sensor value. This is just a variable. It's not even a pin. It's going to take the variable that we get, the values we get from the sensor pin, and we're going to store it there. That's why we call it sensor value. It's really important in programming to name your variables so they make sense. Also notice we're following that standard where the first word is all lowercase, first letter in the second word is uppercase. If there was a third word here, it would be in uppercase. Then we're going to do void setup, pin mode, LED pin, output. So because that LED pin is going to be an output, and the sensor pin, not surprisingly, is an input. That's got the potential sensitiometer. All right, so now we've initialized the variables. We've done the setup. Now we're going to do our loop. Sensor value equals analog read sensor pin. Well, again, sensor pin is hooked up to A0. This is reading from the potentiometer. In this case, the sensor is a potentiometer, right? Think of it that way. Analog read, not digital, analog read, store it in sensor value. Display write LED pin high. That turns the LED pin on. Delay according to the sensor value. Stop the programming for that many seconds. Then write it low, turn the pin off, and then delay the sensor value. So this is basically a blinking program that you're controlling with your potentiometer. Now, as you look at this, one habit I want you to think about is, changing the code, playing with it a little bit. And some of those ideas, we're going to set a threshold and execute LED fading, which remember that's going to have to involve some hardware changes possibly. Okay. Now, let's do setting the threshold. If that last program, you saved it, I hope, before you do this. So before you go any further, make sure you save the program that was working. We always want to do that. So if we make changes, it won't work anymore, we at least can go back to our old program. So if the other one was potentiometer delay, if you wanted to call it that, or controlling the blinks, or whatever you want to name it something that'll make sense to you. We're going to go through here, and we're going to try something new right now. Sorry about that beep going on right there. Okay. Sorry about that beep. All right. So for the fact of this, we have a threshold of 512. Sensor value equals analog read, sensor pin. So wait a minute, let me just back up on this. I'm sorry. You have sensor pin equals 0. LED pin is 13. Sensor value is 0. Same thing we just had. These are all the same. LED pins and output, pin mode, sensor pins and input. And by using useful names too, it's easy for us to remember what these do. Now we're going to do an if-then statement. And now it's going to say if we're going to set the threshold to 512. The potentiometer can go from 0 to 1023. So we're going to set this threshold value to 512. Sensor value, take the analog read, that's line we had just a minute ago, and it says if the sensor value is greater than threshold 512, digital write the LED pin high, else write it low. So what you're going to do is you're going to use your potentiometer, and then that way you can set it to turn it on or off. Now one thing you can do too is if you want to take a look at this, is we can go ahead and add serial begin up here, and we can add serial print so we can actually see our sensor values. And that might help you understand this a little better. So that's just two more pieces of code here. Serial begin, serial print sensor value. So we added serial begin at 9600 right up there, and this reports the value to our serial monitor, which we used to use in our input webinar. Now, once we have that, let's talk about manage LED lighting. And let's dim the light according to the potentiometer. So in this case, we're going to now, if we just did a program and we had that one threshold, you might name that threshold mechatronics or threshold or whatever you can name that program. Let's do a new program. All right. And in this new program, we're going to have sensor pin again as 0. Notice LED pin is 9. We've changed LED pin to 9. What's 9 different than 13? Well, 9 is a PWM capable pin. 13 is a pure digital pin. So we're going to say pin mode LED pin output, pin mode sensor pin input. So we're going to make LED pin and output just like before, except it's not 13, it's now 9, right? Because we defined it that way. So we're saying 9, assign it to LED pin. Pin mode sensor pin input, that's still going to be the 0 that we had before. All right. Now we're using a different value, but you could have used sensor value. We just called it value in this case, just to mix things up a little bit. Integer value equals analog read sensor pin. That's, remember, what we're getting off our potentiometer. And we're going to divide it by 4. And then analog write LED pin value. So this value is going to be, because we're using analog write, not digital write, analog write, we're going to change that value. The reason we do that is because that LED pin takes a value from 0 to 255. Our potentiometer goes from 0 to 1023. So we divide it by 4. It makes it much easier. It allows us to control it. So it gives you the full range of the potentiometer. Otherwise, the potentiometer would flick it once it went past quarter of the way up. The LED would be full bright, and every value above that 255 would just stay bright. So we're trying to basically change the potentiometer value so that the highest potentiometer value is 255 in this case, because we're dividing it by 4. All right, that gives you a good example of how we use potentiometers. In our next lesson, we're going to tie this in with servos. All right? So if you've done this and it feels pretty good, save this and then go right on to servos. You might find that pretty helpful. Well, that's it for now.